We're going to take a look at angles, relationships within angles, how to find missing angles, as well as copy and bisect an angle later on in the lesson. So when it comes to angles, first thing we need to know is a whole bunch of definitions. Here we have the angle is the union of two non-collinear rays that share a common endpoint. What that looks like is I have a ray going off in one direction, and then I have another ray going off in a different direction. And the resultant space in between is what's known as an angle. So this here is going to be an angle. Commonly we use theta. It's a Greek letter. Basically it's a placeholder for angle measurement. It doesn't necessarily mean that there is a set degree within the angle, but it's just a placeholder. The interior of the angle is always the smaller of the region defined by the angle. So again, if I have the same thing going on, I got a ray going off in this direction with a ray going off in a different direction. The part that is inside here, the smaller part, is what's known as the interior of the angle. Conversely, the exterior is going to be on the outside. The vertex is also the common endpoint. So ray in this direction, a ray in a different direction. This is the vertex right here. Degrees, the angle measure formed by dividing the distance around a circle into 360 parts. So what that means is if I were to take a circle and divide it up, I could technically break this up into 360 parts, each of these being worth 1 degree. So an angle is going to be comprised of many degrees, part of a circle. Opposite rays, two rays sharing common endpoint with a 180-degree angle. Basically, it means I have one ray going in one direction and the other ray is going in the complete opposite. So if one ray is going to the right, the other ray is going to be going to the left. And what this does is basically creates a straight line, which results in a 180-degree measurement. Now in this example here, we got to find two rays, name the sides, name the vertex, and the angle in 4 different ways. The two rays are going to be the two sides of it. Essentially, we have ray EF and ray ED. So from E to F and E to D. And the sides are going to be the same thing, ED and EF. The vertex is the point where the two rays meet. So here they meet at point E, so that is the vertex point E. Now naming the angle in 4 different ways. When you name an angle, typically we want to use 3 letters. And the order is only semi-important. The only one that's really important is the middle letter. So if I'm using 3 letters, the middle letter is actually going to be the vertex. So here we could say we have angle DEF, angle FED. And in situations like this where we just have a single angle, sometimes they'll just use the vertex, angle E, and sometimes they'll use the variable that is being used as a placeholder for the actual degree measurement. So here we have Y being used as a placeholder, so they can say angle Y. I'm not a fan of the last version because it can be kind of confusing, especially later on when we have multiple angles kind of conjoined. Right angles, 90-degree angles. So this goes back to the segment and segment bisector. So if I have an angle here and an angle straight down, I now have a right angle, usually noted by a little red square in the corner, and that means 90 degrees. An acute angle is an angle with less than 90-degree angle, with a less than a 90-degree measurement. So a very small angle, this would tell me we have an acute angle. An obtuse angle would be an angle that is between 90 and 180 degrees. So if I have a ray going off in one direction and ray making that, we have a nice large angle. This is going to be greater than 90 degrees. So this is going to be an obtuse angle. D is, so here we have a little bit of practice with an actual diagram. D being a point in the interior of angle ABC. Angle ABD is worth 15 degrees and DBC is given a value of 90 degrees. We need to find angle ABC. We have to name an acute angle, we have to name the right angle, and an obtuse angle. We can already name the acute and the right angle because they already give it to us. We learned that an acute angle is less than 90 degrees. Well, they already told us that ABD is 15. 15 degrees is definitely less than 90 degrees. And we also learned that a right angle is exactly 90 degrees. And they give us here that angle DBC is 90, so we can just state angle DBC is the right angle. What we have to do now is find ABC and name the obtuse angle. So we were told that this angle here, angle ABD, is worth 15. And we are told DBC is worth 90 degrees. We need to find ABC here. Basically, we were given the two small parts. We were told this part of the angle is 15. This part of the angle is 90. All we have to do now is add them together. 15 plus 90 means we have a 105-degree angle for angle ABC. And we just learned that an obtuse angle is any angle greater than 90 degrees less than 180. Well, 105 is between 90 and 180. So angle ABC is going to be the obtuse angle. An angle bisector, very similar to a segment bisector. A segment bisector cuts a segment in half, so an angle bisector is going to cut an angle in half. So essentially we have an angle. So a ray going off in this direction and a ray going off in this direction. The bisector is another ray that cuts it in half. So in this case, this is going to be the angle bisector. Because what this does is, let's say the whole way across here is some given value. We'll use theta. The angle bisector will cut it in half. So what this does is this section up here, this part right here, from the top ray to the vertex out through the bisector here, this is going to end up being half of whatever theta is. And again, it's half, so this means this other section is also going to be half of whatever our full angle is. And we can use that to our advantage later on when we have to solve mathematical problems. For instance, we have CD here bisecting angle ABC. We have to name angle 1 in two other ways. So angle 1 is this part right here. Now I always say follow where the arcs touch. So from here to the vertex back up, we have our three letters, A, C, D. So we can say angle A, C, D. And we can also go in the other direction as well. We can go from D to C to A, or angle D, C, A. Now we have to state that two angles are congruent. So again, we have a bisector. It means it cuts it in half, meaning the two parts are going to be the exact same measure. So this means angle 1 is going to be equal to angle 2. And it's the same thing for letter C, conclusion that states the two angles have the equal measures. Well, we just pretty much did the same thing. Angle 1 is equal to angle 2. Number 4 says we have PB bisecting angle APC. We are told APC is worth x squared minus 2x and APB is 4x minus 12. We need to find angle CPB. So anytime we have a diagram like this, we should mark it up and label what we know. So we know angle APC is x squared minus 2x. We are told angle APB is 4x minus 12. Now we also know that because of this bisects, what it does is it creates two equal halves. So if this half is 4x minus 12, then this half, BPC, is also 4x minus 12. And in math, the sum of the parts is equal to the whole. So if I add the two small parts, so if I add my 4x minus 12 and 4x minus 12, I'm going to get the whole thing, x squared minus 2x. So 4x minus 12 plus 4x minus 12 is going to give me x squared minus 2x. On the left-hand side of the equal sign, we're going to combine our like terms. So we got 4x and 4x. That's going to give me 8x. We have minus 12 and minus 12. So minus 24 is going to give me x squared minus 2x. Now, because I have the x squared, it tells me I'm dealing with a quadratic equation in some fashion. So I'm hoping to be able to factor this. And in order to factor, my equation has to be equal to 0. Life is so much easier when x squared itself is positive. So as long as it's positive where it's at, I'm going to leave it, and I'm going to worry about whatever else is on the other side. If it's negative, that means I'm going to move the side with x squared over to the other. Here we have x squared. It's positive. So I'm going to leave the right side alone, and I'm going to move whatever I have on the left-hand side. So to move the 8x over, I do the opposite. So no sign means positive, so we have to subtract the 8x. And to move the 24, I have to do the opposite. So here we're subtracting, which means I have to add 24 to both sides. And I'm going to line up the 8x underneath the 2x and the positive 24 underneath on the other side, since it's just a solid number. What this does is the 8x's cancel, the 24's cancel. So I now have 0 equals x squared minus 10x plus 24. Now what I want to do is I want to factor. And when I factor, I end up with 0 equals. I'm going to create two sets of parentheses. I'm going to end up with two binomials. The first term in each parenthesis will multiply to be x squared. And the only way to do that is x times x. So x times x gives me that x squared. Next, I have to come up with a number. And what the number does is the numbers will multiply to be 24, and they'll add to be negative 10. Life is much easier if we just list off the factors of 24, because there's many ways that I could come up with negative 10 through addition or subtraction. There's only a few ways that I could get 24 if I'm multiplying. So if I list 24, I know I know that factors of 24, I can do 24 times 1, 12 times 2, 8 times 3, or 6 times 4. So I only have 4 possible options here, and I could do trial and error, or I could come up with a way to figure out right off the bat which number I need. We know it multiplies to be a positive 24. And when I multiply, the way to get a positive is by multiplying numbers with the same sign. So this means I'm either going to multiply a positive times a positive or a negative times a negative. The question becomes, which pair am I going to use? Am I going to do plus plus or minus minus? This is where the middle term comes into play. Whatever sign is on the middle term, that's the pair that I use. So here we are subtracting the 10x, so that means I am using minus minus. And now I need to come up with the numbers that when I add them together, when they're both negative, that I get negative 10. So if I do negative 24 minus 1, I'm going to get negative 25. So that's not an option. If I do negative 12 minus 2, I'm going to get negative 14. So that's gone. Negative 8 minus 3 is going to give me negative 11. And again, I need negative 10, so that's gone. Negative 6 minus 4, that's going to give me my negative 10. So subtract 6, we'll subtract 4. From here, I'm going to split these up, and each of them is going to be set equal to 0. So x minus 6 equals 0. X minus 4 gives me 0. On this side, I'll add 6. So I get an x value of 6. And on the other side, I'll add 4. So I get an x value of 4. So again, quadratic equation, I end up with two possible values of x. Question is, can I use both, or is there only one that I can use? Well, if I think about it, x squared, if I were to plug in 6, I would get 36 minus 12. So I would get 24. And then if I plug 6 over here, I get 24 and 24 makes 48 minus 24, so I get 24. So here I get 24 equals 24, so it works out. And if I plug in 4, I get 16 minus 8, so I get 8. If I plug in 4 over here, I get 16 and 16 makes 32. And if I subtract 24, I'm also going to get 8. So 8 equals 8. So both can be used freely. So if I want to find angle CPB, I can actually plug in both 6 and 4, and it will be correct. So when x is equal to 6, I get 24 minus 12, which gives me 12 degrees. If I use 4, I get 16 minus 12, which gives me 4 degrees. So this is an instance where I will come up with two possible answers, and both are correct. In this particular problem, we're tasked with copying the angle below. So copying the angle does not mean I use my ruler and then a protractor to measure the angle and then mark it off on the side. We're going to be using our compass and ruler in order to do this. So first step, what we want to do is we're going to take our ruler and we're just going to draw a straight line. It could be any direction, any size, any length. It really doesn't matter. So I can draw a straight line off to the side here. So now I have one side of my angle here. So I could say this blue line is equal to this bottom part of the angle over here. So the question becomes, how do I figure out where I'm going to draw this other ray? Well, what I want to do is I want to get my compass, and I'm going to put the bullseye end, or the non-pencil end, on the vertex. And I'm going to open up the compass as far as I want. It really doesn't matter how far you want. And I'm going to mark it so that I run through both edges. And what I'm going to do now is I'm going to do the same thing on what I just drew. So I'm going to take my bullseye end, I'm going to leave the pencil where I had it, and I'm going to make a nice large semicircle on the vertex. My next step is I am going to take my compass, I'm going to put my bullseye on one of the points of intersection. It really doesn't matter. In this case, I'm putting it on the bottom part of the angle. So you can see here that this is where I'm putting my bullseye or non-pencil end. I'm opening it up to the other side so that my pencil is now on this point of intersection on the top right. Once I'm here, I'm just going to make a mark. So notice my black arc and now my green arc are meeting where the top ray is going off to. What I'm going to do now is essentially the same thing. So here I had it on the point of intersection on the bottom ray. So I'm going to move the compass so it's on the intersecting point of the bottom ray. And I'm going to mark through my other semicircle that I drew. Now I have a point of reference. So this point of intersection is where I'm going to draw the other ray through. So I start at the vertex and I run through that point of intersection. I have now copied the angle that we were given. And if you're not 100% sure, you could get out the protractor. So for instance, if we were to measure the degree of this particular top angle, we would line it up. We would put our center on, we make sure we're lined up nice. We can see we have just above a 50-degree angle. If I were to move it over to this one, again, make sure everything is lined up, you can see we have just over a 50-degree angle. So using those couple of marks, we can copy an angle. Again, we can copy any angle that we are given using the same thing. So here we are tasked with copying this particular angle. We're going to need our protractor, or not a protractor, our compass. Step one, we're just going to use the ruler and we are going to draw a ray off in any direction. Doesn't really matter. I'm going to take my compass, put the bullseye on the vertex of the angle, and open it up. And I'm just going to mark it so that way there I run through both sections, both rays of our angle. And I'm going to do the same thing. I'm going to move the compass over to the vertex of our drawn ray. And I'm going to make a nice giant mark since we don't know where the point of intersection will be. From here, I will put the bullseye on one of our intersecting parts, open up our pencil so that it's now on the other point of intersection. So the compass, we have the bullseye end on one section, on one part, and we got the pencil on the other ray. Once we're satisfied with where we're at, we can make a mark just so that way there we're sure. And because the sensor on a computer screen, close enough, we will move the compass over so it's on our drawn ray. And we are going to make another mark once we are satisfied with where our bullseye end is. We'll move our compass off the way. Now we will use our ruler to run through the point of intersection, and we have successfully copied our original angle. And this one is going to be the same process. Step one, we're just going to draw a ray off to the side using our ruler. Then we're going to use our compass. We're going to put our bullseye end on the vertex, and we're going to open up our compass as far as we want to so that it's on the line, and we're just going to mark it so that it runs through both rays of our angle. Next, I'll put the bullseye on our drawn ray and make a wider mark so that way there I know where an intersecting point will be. From here, we'll put our bullseye end on one of our intersecting points, and then make sure that the pencil is on the other intersecting side of our angle. We'll make a mark. Again, sensor on the computer close enough. Undo. And again, once you measure, it's going to be the same on both sides. So put bullseye on your end, mark it, and now you have a point of reference to run the angle right through. So there's our intersecting point, and we can draw another ray, and we have now copied this particular angle. Same thing with that one, follow the same steps as for this one. This particular problem, we are tasked with bisecting the angle. So bisecting means we're going to cut this in half. So again, we're going to use the compass, and we're actually going to be using the pretty much the same methodology as we did for copying the angle. What we want to do is we want to put our bullseye on the vertex, and we're going to open up our compass as far as we want. It really doesn't matter. Once we're satisfied with our bullseye and where we want to mark, we're just going to run it through both sections. Now this is where we start to diverge a little bit from it. Before copying, we would draw a ray first and then measure across. We don't have to draw a ray. Basically, we're just going to take this and we're going to measure across. So bullseye will go on one of our drawn points of intersection, and we are going to open it up so that we're all the way across to the other point of intersection, and we are going to mark out into the angle itself. And then I'm going to flip it and do the same thing. I'm going to move the bullseye to the other side and make sure the pencil is on the opposite side. So we're opened up all the way across our angle here, and we're going to mark out into the angle. Now we have this point of intersection here, and that is where I will draw my ray through. So we're going to start here at the vertex and draw on out using our ruler. And what we did now is we now bisected this particular angle using 3 markings. And if I wanted to do the same thing with this one, compass, if I were to bisect this one, I want to open up our compass out a little bit. So bullseye end on one part, and we are going to open up however far we want and make sure that we run through both. What I'm going to do now is I'm going to move the bullseye end to one of our drawn intersecting points and open up our pencil to the other side. Once I'm satisfied, I'm going to draw out into the angle and then reverse it so that my bullseye is on the other side and pencil on the opposite side, and we're going to draw on out. Once we have a point of intersection, we can draw a ray from the vertex through that point of intersection, and we now bisected the angle. And we can do that for every angle that we want, whether it's bisecting or copying, and all the mathematical involvement of finding measurements, knowing that halves are the same once we are bisected. So this section and this section are the same thing. So this side and that side of the angle are going to be the same exact measurement.